This video is about writing linear inequalities from a graph. So we're going to take a graph like the one below here on the left and write the inequality that corresponds to the solution that is graphed here on the left. So on the left here, we have a graph of a linear inequality. There's a boundary line that's dashed and it's shaded in one direction. So we're going to find the equation of that boundary line and then to figure out whether we need to put a greater than or equal to sign in or a less than or equal to sign. So we'll need to pick out which symbol we'll use once we know the equation of the boundary line. So to figure out the equation of the boundary line, we're going to look at a couple characteristics. We need to know its slope and its y-intercept. This particular example has points that go through -2, 3. That's the first red dot on the left. 3, -2. And if I look a little bit closer, I can tell that it goes through 0, 1 as the y-intercept. So I actually know already that my y-intercept is going to be 1. Let's take a look at this. From the first red dot, it goes down 1 over 1, and it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over. That means that the slope, right, rise over run, is -1 over 1. Okay, our slope is just -1. It goes down 1 over 1 every time. So the equation of our boundary line is y equals -1 times x plus 1, okay, or -x plus 1. That's our mx plus b form of the boundary line. Now because the boundary line is dashed, we actually know that our boundary line is not part of our solution. So we're either going to have a greater than sign or a less than sign, but not an or equal to sign. So the last thing we need to do is figure out whether it's going to be y is greater than -x plus 1 or y is less than -x plus 1. And they've highlighted this point here, 0, 0. 0, 0 should be a solution. So I'm going to write that down. 0, 0 should be a solution. And I'm going to abbreviate the word solution here. So 0, 0 should be a solution. And the two options we have are that y is greater than -x plus 1 or that y is less than -x plus 1. So we're going to plug 0, 0 into both of those and see which one comes out to be a solution. So perhaps 0 is greater than -0 plus 1, or perhaps 0 is less than -0 plus 1. Well, here on the left, we get 0 is greater than +1. Well, that's not true. And here we get 0 is less than +1, and that is true. So this inequality, y is less than -x plus 1, is the inequality that corresponds with our graph because we found that 0, 0 was a solution of that inequality and we had already found our boundary line. Here's our next example. We're going to do the same thing. We're going to find the boundary line, decide whether it should be less than or greater than versus less than or greater than and equal to, and then we'll decide whether it needs to be less than or greater than depending on which way the graph is shaded. So first we need to figure out something about this boundary line. So here, I see that there's an x-intercept at 2 and a y-intercept at -4. So there's a point at 2, 0, and a point at 0, -4. And the y-intercept being at -4, so I know that the b value in mx plus b is going to be -4. And then our slope, we need to take a look at that. So let's see, if I'm going to go over 1, so from 0 to 1 on the x-axis, that happens here. So how far do I need to go up to get there? Well, I need to go up 2 in order to go over 1 on this graph. So our slope is 2 over 1, which is 2. So our boundary line is y equals 2x minus 4. And the question is, are the boundary solutions part of the solution? And in fact, this time they are. So the line is solid, which means we either have a less than or equal to or a greater than or equal to situation. So the last question is it y is greater than or equal to 2x minus 4 or y is less than or equal to 2x minus 4? Now, 0, 0 is not part of the solution set, so I'm going to take a different point to check. Let's check 3, 0. So 3, 0 should be a solution. All right, so 0 greater than or equal to 2 times 3 minus 4, or 0 is less than or equal to 2 times 3 minus 4. So 2 times 3 minus 4 is 6 minus 4. So 0 is not greater than or equal to 2, but 0 is less than or equal to 2. So y is less than or equal to 2x minus 4 is the inequality that goes with the graph we started with. All right, our third example has a dashed line with a negative slope and it's shaded above. So let's see what happens here. We have a y-intercept of positive 4. And it looks like our slope goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. We know that that means that our slope value is negative 1. So our boundary line is y equals negative x plus 4, but that boundary line is not included in the solutions because it's dashed. So dashed line means that we're working with either less than or greater than. So we need to check a point that is a solution to see if either y is less than negative x plus 4 or y is greater than negative x plus 4 is the inequality described by this graph. So let's see, let's pick the point 3, 3 is a solution. So let's see, 3 is less than negative 3 plus 4. Well, 3 is not less than 1. So let's see, 3 is greater than negative 3 plus 4, while 3 is in fact greater than 1. So yes, y is greater than negative x plus 4 is our inequality. Okay, in this example, we have another dashed line. We're shaded above again, so we need to find the y-intercept and the slope value. The y-intercept actually goes through 0. Okay, so our intercept is at 0, 0. And our slope, let's see. So in order to get to another whole number set of coordinates, we have to go to there. So we go down and over. So we go down 3 and over 2. So our slope is negative 3 halves. Our boundary line then is y equals negative 3 halves x plus 0, which I don't need to write. And our boundary line is not included, okay, because it's a dashed line on the graph. So we're either dealing with less than or greater than. So it's either y is less than negative 3 halves x or y is greater than negative 3 halves x. You've probably noticed, okay, that if it's shaded above, it's going to be greater than. If it's shaded below, it's going to be less than. Let's double check with a point anyways. Let's check with the point 0, 1. So that means 1 is less than negative 3 halves times 0, or 1 is greater than negative 3 halves times 0. Well, 1 is definitely greater than 0, so y is greater than negative 3 halves x is the inequality that matches this graph. We need to know the slope, we need to know the y-intercept, we'll figure out if it's dashed or not, and then which direction to shade. Here, our y-intercept is at negative 2, and let's see what our slope is. Well, to get from this point to this point, there's no rise. There's a rise of 0, even though there's a run of 2. And no matter which points I picked, there would always be a rise of 0. This has a 0 slope because it's a horizontal line. So in fact, this is the boundary line is like y equals 0x minus 2. Well, 0 times x disappears. The boundary line in this case is y equals negative 2. And you should remember that every horizontal line has an equation that says y equals some constant number, whatever the y-intercept is. So the only thing we need to do is figure out whether it's greater than or equal to, less than or equal to, or just greater than or less than. Well, we have a dashed line, so that means that it's not or equal to, so we're either dealing with less than or greater than, and since we know that that it's shaded up, the y values go up to negative 1, 0, 1, 3, so we know that everything greater than negative 2 is our answer. So y is greater than negative 2 is the inequality graphed here. Our last example is a little bit different than the previous 5. We would normally find the slope and the y-intercept to write our boundary line in mx plus b form. However, here our boundary line, okay, this vertical line here doesn't have a y-intercept and its slope is undefined. Okay, there's no y-intercept to be found, and the slope is undefined because if we took these 2 points, say if we took negative 2, 3 and negative 2, 1, the rise would be a positive 2, but the run, the distance moved horizontally would be 0, and we can't divide by 0. So the slope is what we call undefined, because dividing by 0 is not a defined number in mathematics. So if our slope is undefined and there's no y-intercept, we certainly can't write this in y equals mx plus b form. And the only other kind of equation we can have that's a linear equation on the plane is x equals some number, okay, some constant number. And in this case, it's x equals negative 2. X equals will get you a vertical line, okay? Some x equals some constant number will get you a vertical line in the way that y equals some constant number will get you a horizontal line. So we have a vertical boundary line of x equals -2, and before I drew over it there, that was in fact a solid boundary line. So we know that we're dealing either with less than or equal to or greater than or equal to. Well, the x values go up to -1, 0, 1, 2, etc. Okay, they go up from -2. So we know that x is greater than or equal to -2 is the inequality that describes the graph we were given.